Hello everyone, myself Anugraha Ganesh TG from 1st MSc Physics, Hindustan College of Arts and Science, Coimbatore. Today we are going to discuss about the topic critical point. As you all know that critical point is a point on the isothermal for the critical temperature at which a change of state from the gaseous state to the liquid state takes place under constant values of Pc and Vc. We can simply say that critical point is a point which indicates the change of state from the liquid state to gaseous state. Next, we can see the critical point from the phase diagram on taking temperature on x-axis and P pressure on y-axis. From this phase diagram, we can study the different phases of matters, that is the solid phase, liquid phase and gaseous phase, and also it is converted through the different process like sublimation, melting and evaporation. Triple point and critical point is also marked on this diagram, and critical point is taken at the critical temperature. Critical temperature is the temperature which is highest point where the liquid phase exists. Okay, next we are going to discuss about the properties of matter near critical point. That is, the matters existing around the critical point has 5 properties. So, the first one is the density of the vapor and the liquid generally approach each other and the densities are equal at the critical point. It says that the matters existing near the critical point, that is both the liquid phase matters and gaseous state matters, is having equal density. Second point is that at the critical point or just near the critical point, the line of demarcation between the liquid and vapor disappears. Consequently, there must exist mutual diffusion between the two phases and the surface tension must be zero. This also means that the force of intermolecular attraction in the liquid and vapor state must be equal at the critical point. So, from this point it is understood that there won't be any boundaries between the liquid and vapor state, and also there exists a mutual diffusion between the two phases, and thus the surface tension will be zero and the intermolecular force of attraction in these states must be equal at the critical point. Next point says that the whole mass of the substance exhibits a flickering experience which indicates that there may be variation of densities inside mass. This has been experimentally verified. Fourth point is that the compressibility of vapor becomes infinite at the critical point. And the final property is that the critical point is that point at which the properties of both the phases become identical. These are the properties of the matters existing near the critical point. I hope you have understood the topic critical point we have discussed so far. Thank you.